Hello, I am Dr. Nikhil Patel. Welcome back. In this video, we will create orbital paths for the planets around the Sun that will depict the revolution movements of the planets. And one revolution period equates 1 year for that planet. Earth takes 365 days to revolve around the Sun, and that is equal to 1 year. 365 days and 1/4. So planetary orbits differ for each planet. We'll select curves and nerve circles. Prefer the top view. The planets are difficult to spot, so either of the move, scale or rotate tool, we can use those tools to locate the position of the planet on our canvas. From the center of the Sun to the Venus. We are naming them accordingly. Venus orbit just now. Now we will create orbit for the Earth. There it is, rounded, spotted. That is the Earth orbit. We name it Earth orbit. Mars, curves, nerve circle from the center of the Sun to the Mars. Needs to be enlarged. Naming it Mars orbit. We can group them all. Jupiter, easier to spot, somewhat larger on the canvas. Naming it Jupiter orbit. Go on repeating this procedure. Now Saturn. There we have spotted it in the round. Curves, nerve circle, and the circle stretched to the Saturn. Now naming it Saturn orbit. We will attach motion paths to our planets. We come to Uranus now. We have spotted it in the right side of the canvas. Curves, nerve circle, stretching it from center of the Sun to the Uranus. Naming it Uranus orbit. Neptune and Pluto remain. Same procedure. Marking nerve circle. For Neptune even, we will make that orbit elongated, elliptical. As such, no orbits are circular, somewhat elliptical. Come to Pluto. Pluto is not considered a planet nowadays astronomically. Such a small entity not to be considered, but we are considering it as a planet. And Pluto takes 248 years to complete one revolution. These are the orbits of various planets. Modifying the Neptune orbit somewhat like that. All planetary orbits selected. Is selected. In the perspective view, Mercury selected. Hit F to center the selected object, Mercury here. We are attaching Mercury to the motion path now. Select Mercury, animate, motion paths, attach to motion path. 88 frames would be there, attach. Now Mercury is attached to the motion path. There it goes. It doesn't move beyond 88 frames, what we have assigned. So we have to modify it in the graph editor window. Hit F to center the graph. Select it. Even if you don't select it, it doesn't matter. Make the tangents linear. That will smoothen the movements. And select Gauss post-infinity cycle. That's done. Mercury will have revolutionary movement infinitely around the Sun. That is the example of Mercury attaching to orbit, being attached to orbit. We can use that principal method to other planets and even to moons of the planets. We will see rotational movements as well for the planets in the next videos. These are some astronomical data to be applied to the animation that can be useful. Thanks for watching. Bye.